but officially we'd have to multiply mg. Mass we know, definitely know. Weight 4 is easy enough. R5, I need to give you radius, so let's go ahead and give you some numbers here. Radius of the wheel will make 0.5 meters, and the mass of the wheel, or pulley, radius of the pulley, mass of the pulley is 2 kilograms. So R5 we'll know, R4 we know, I we can calculate. Might seem like the moment of inertia of P is an unknown, but there's a formula for it. So let's do substitution. Formula for weight in unison. This is gonna be great. 3, 2, 1.
mg.
Oh, and the enthusiasm is infectious.
He still said 1/2 mv squared.
So I have M5G minus FT5 equals M5A. That one, FT4 minus M4G equals M4A. And then I'll bring it in over here. We have FT5, R5 minus FT4, R4 equals moment of inertia of the pulley. Consider it a solid disk.
1/2 mr squared.
So 1/2 mass of pulley, radius of pulley squared times alpha. There is a formula for alpha in terms of A. I'm just going to hold off just a moment on that one. So I have M5G minus FT5 equals M5A. FT4 minus M4G equals M4A. Then those R's are the same, so I'm just gonna, so with FT5, radius of pulley, probably should use the same R, use lowercase there. Oh, just continue to erase it. There we go. R squared, all right. Minus RPFT4 equals 1/2 MP RP squared. All right, so now alpha. What is alpha in terms of A? Let's narrow it down some. I'm looking at a point on the edge here. This is supposed to be round. A point on the edge, and it has traveling at some speed v, and this thing is rotating at some angular speed omega. What is the relationship between v and omega? That is one that we've done before. If not sooner, would have done it when we talked about centripetal acceleration.
V equals R W, omega.
All right. So I know that V is equal to R omega. If we take it one step back, arc length is equal to R times the angle. But so now A is equal to R alpha. You want a sort of pseudo derivation here. This is, if V equals R omega, then the change in V must be R times, well, must be the change in R omega. R is a constant, so this becomes delta V is equal to R delta omega. They're going to happen for the same amount of time. Well, change in speed over time is this acceleration here. Change in omega over time is that acceleration there. Notice this is angular acceleration as opposed to centripetal acceleration. So it's how quickly this V is changing, and is not taking into account the fact that there is a net force towards the moon. So alpha is R, would be A divided by R. Since the acceleration of the rope or the masses has to match the acceleration A of a point on the outside of the circle, on the outside of the bullet. And that's RP. So now we can cancel stuff out. That RP is going to cancel out with one of those. So I have three terms here. I have this term, and this term. All of them have RP in it as a factor. So I can cancel that out. That cancels, the remaining one cancels. So my equation there simplifies down into ft5 minus ft4 equals 1/2 mass of pulley times the acceleration. I now have three equations, three unknowns. And those are my three equations. My unknowns are A, ft4, ft5. So we just need to solve for it.
So I have M5G minus FT5 equals M5A. FT4 minus M4G is M4A, and then FT5 minus FT4 is 1/2 mass of pulley times A.
I think that's what it was. Now I just add them. Conveniently, I can just add them. If I add up the left-hand sides, I'll have an FT5 and a negative FT5, FT4 and a negative FT4. That's all gonna go away. So what I'm left with is M5G minus M4G. On the right-hand side, I have M5A plus M4A plus 1/2 MPA. When we solved this the first time, if I dropped out the pulley part here, that's what we had. But we have the pulley part now. So this is M5 minus M4G equals M5 plus M4 plus 1/2 mass of pulley A. So acceleration is going to be that divided by this. So my acceleration is going to be 1 times 9.8 over 5 plus 4 plus 1/2 times 2. So 9.8 divided by 10. All right? Yeah. Which is 0.98 meters per second squared. If we compare that to what we had the first time, by bringing in the mass of the pulley, we have additional mass that we have to move. I would expect the acceleration to be less, and indeed it is. Oops. and just a little bit of reality. Brought our numbers down. Questions, behavior? All right, let's drop back for a little bit. Let's make something a little bit simpler. I have a beam being held up by 2 wires. Mass of beam will make 10 kilograms. No, let's change that. Let's make it 5 kilograms. Length of beam is 8 meters. Distance from here to here is 2 meters. The distance here to here will make 3 meters. The beam uniform mass distribution. I want to know what is the tension in the 2 wires. The beam is in static equilibrium. Static, rotational, and linear equilibrium. So it's just sitting there. I have 2 wires, so this is FT1, FT2, and just for the sake of simplicity, I'm going to call that A and I'm going to call that B. We're going to solve it through the same steps that we have been doing. Just recognize that we will have a K-hat equation, which it does bring up. Let's go ahead and define things. So I hat, J hat, K hat.
Is that circles us to represent an arrow pointing towards us?
Yeah, the dot actually represents the.
Yeah.
And it'll be an X if it's away.
Yes. First step, force diagram. All I care about are the forces acting on the beam. So what forces are acting on the beam?
Fate and tension.
Yeah. Well, the tensions I gave you there, so I have A pointing up here, I have B pointing up there, and then the uniform mass distribution, this is just basically saying that we can consider the weight to be smack dab in the center of the beam. So 4 meters from each edge. Weight. Acceleration of the beam.
0.
Say again?
0.
Yes. How do you know?
Static.
No.
Equilibrium.
Yeah, that's the one. Coordinate system. Well, we did that first. Decomposition. All right, shaking your head no, Natalie, because we don't have to break anything up? My grandfather used to shake his head when he couldn't hear, so way to bring back those memories. So am I gonna decompose anything? All right,
You said there,
pardon?
yeah, but I don't know what it is. You said there was gonna be a K-hat.
Yeah, but that doesn't mean I have to decide to break anything up. All right, and I don't. Then equations of motion. There'll actually be two equations of motion. I did not have to actually define the I-hat direction. It depends. All right, so what are my two equations of motion?
J hat y equals negative y equals ma.
Say that again?
Or J hat
Yeah.
negative w is equal to m times 0.
You're missing something there. Some things.
A plus B minus
Oh.
B.
Yeah. Equals mass times 0. All right, there's one. And now the torque equation. Because I have two unknowns. I don't know, well, wait, I can figure out. I don't know A, I don't know B. I have to have another equation. So if we're dealing with the door, there's a natural axis of rotation, something that makes sense. In the case of this, yeah, there's a natural tangent. But on something that is not moving at all, where do you pick your axis of rotation? Because I know torque is R cross F. R is the moment arm, which is the vector from the axis to where the force is applied. So I need to know the axis. What axis do we pick?
Probably be A or B. I just don't know.
Or is it either one of them? Or
But-
you're just narrowing it down to two?
I just know, I think I know it's those two just because it's, but I don't know which one it would be because since it's the 3 meters and the 2 meters, don't remember.
If you had to bet, which one would you bet on?
Probably 2?
The B?
B?
Reviews? Okay. Anyone else?
What's the exact question again?
What do we have to decide upon an axis of rotation? To figure out torque, we have to figure out axis of rotation first. So, what do you choose for something that is just sitting there?
Be the middle between them?
So between the two, between A and B, or,
The center between A and B.
okay? Anyone else?
2.
As in, do you agree with Stone?
Yeah.
So we have the choices right now, so there was halfway between these, which would be,
A, B.
so somewhere
Just
around
maybe over
here.
3, or just be 4.5, I guess.
So that would be 5.5
Oh.
and 4.5. Oh, wait, no. That's right, it's only 8 more. So that's 3 in between.
Yeah, so 4.5.
Yeah. 4.5 and 3.5. And then there's a deciding here at B, so that is 6 meters. Anyone else?
I changed my answer to A.
Okay, all right, so we got here.
Yeah.
Anyone else?
I think it's closer to the center.
Why not just pick the center?
Because when it hangs, the difference of like the 3 and the 2 makes it like different.
And if my thought process is if wind blew on it, I think the B side would blow more. Like, I don't
Yeah,
know if that
but
makes sense.
so then-
That's just my thought process.
Stone, you were about to say something?
If the wind blew it would mean that A would move more, right? Because it does like
If
less
the wind were
tension.
blowing, it's not static equilibrium anymore. We're in a different
But
problem.
I'm just saying that's my thought.
Dominic?
With their thing, I feel like it would be closer to B than A, but it wouldn't be at either though. I don't think A or B would be the center or the axis.
Alright,
Like it'd have to be somewhere in between.
those who haven't said anything yet, do you wanna put in your 2 cents? It's a shame, because you can't be wrong.
A squared plus B squared equals square root of that.
So all three of us were wrong.
From the left-hand side or something?
We're all right.
Okay. Anywhere, we're looking for a location,
Oh.
anywhere works, I could pick a point out here, it doesn't even have to be on the beam. Any place works, if it's in static equilibrium. Typically, you pick a place where an unknown force is acting, so I would recommend A or B, but it doesn't have to be. Depends on how much math you wanna do. Alright, so let's start with A, then we'll solve another one and see if we get the same answer. Alright, so this is our axis right here. Our torque equation, R cross F. So we have a zero vector cross A, which is gonna be zero.
A zero vector.
Again, pushing on the hinge, that doesn't do anything. Plus weight, so that is, R is a vector that way,
Yeah, that's right.
which is 1 meter. I hat, cross, mg, negative mg, j hat. Plus,
That's a 1.
this one, the R is a vector going this way, and that is gonna be 2 meters, so negative 2 meters I hat, cross, negative mg, j hat, equals the moment of inertia times 0.